Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
In this problem, we're given a position-time graph of a bus and its motion. We're asked to find the average acceleration of the entire problem. So if you just use the definition of the average acceleration, it's whatever your starting speed and your final speed are. It's the difference between those divided by the entire time for the trip. So in this graph, they give us 3 sections, but all we really care about is section A and section C, because section A will give us the initial, and section C will give us our final velocity. So in the data for section A, it looks like we have a initial position of 0 and a final position of about 24 kilometers. And then the time interval is 0 to 1 hour. So the velocity for that section, the velocity for section A, would be 24 minus 0 divided by the time interval, 1 minus 0. So that gives us 24 kilometers per hour. For section C, we have an initial position of about 33 kilometers and a final position of about 27. The time interval for the starting point for section C is about 2.2 hours, and the final time is 3.5. So the velocity for section B would be the 27 kilometers minus the 33 divided by the difference of 3.5 hours and 2.2. So we have negative 6 kilometers over 1.3 hours. And that gives us a velocity of negative 4.6 kilometers per hour. Your numbers might be slightly different because you're sort of estimating when you look at a graph without fine precision. So now we need to find the overall change in velocity. So we started in the first section with a velocity of 24, and we ended with a velocity of negative 4.6. So our acceleration is going to be the final velocity minus the initial over the time interval. So negative 4.6 minus 24 divided by the total time for the whole trip, which is 3.5 hours. And that gives us an acceleration of negative 8.2 kilometers per hour squared. So again, this could vary based on what you estimated for the values for both position and for time. And so it should be something close to negative 8.2.